Okay, now we're going to move on into section 4.5. Really, this is just a continuation of this proving triangles congruent by some of their parts. Okay, and this particular section deals with angle side angle and angle angle side. So we're going to start with angle side angle congruence postulate, or also known as ASA postulate. The statement of that postulate is this: if two angles and the included side. Now we're going up to this term included again that we defined back in 4.4. And basically the included has to be what? Whatever is included is between two of something. On this one, since we're talking about two angles, the side is sandwiched between the two angles. It is between the two. It's a filling. So, two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay? So let's do an example. Again, we have triangle ABC and triangle DEF. And what we've marked is angle B, which corresponds to angle E, and we've marked angle C, which corresponds to angle F. And then we've marked the included side. Over here on ABC, triangle ABC, the included side is segment BC. On DEF, the included side is segment EF. Okay? So by the postulate, the ASA postulate, we have shown that triangle ABC is congruent to triangle DEF. Okay? Now, in order to get our CPCTC correct, again, there's that abbreviation, CPCTC becomes very important. We're going to stack these on top of each other to make sure we're corresponding, that the points, the corners of the triangle are correct and corresponding with each other. So we have triangle ABC stacked on top of triangle DEF. That means that angle A corresponds to angle D, and they are congruent. Angle B corresponds to angle E, and they are congruent. Angle C corresponds to angle F, and they are congruent. It also means that segment AB corresponds to segment DE, and they are congruent. Segment BC corresponds to segment EF, and they are congruent. And segment AC corresponds to segment DF, and they are congruent. Why? By CPCTC. Have to know what that means and be able to use it. Now, let's do an example using this and prove two triangles congruent using the ASA postulate. Okay, now let's use this particular postulate to actually prove two triangles congruent. Okay, and we're given this figure right here, triangle ABD, triangle ABC, triangle DBC. Okay, and we're given that segment BC is perpendicular to segment AD. So BC, segment BC is perpendicular to segment AD. Well, what does that tell us? Well, it tells us that that is a what? A right angle. Well, what's this one over here if it's perpendicular? There's two right angles, aren't they? Okay? What else do we know? They also tell us that BC bisects angle ABD. Well, angle ABD is this one right here. If it bisects it, then we know that this angle bisector cuts something in half, creating two congruent or equal parts. So, the congruent or equal parts would be this is congruent to this. So, angle ABC is going to be congruent to angle DBC. Okay? Alright? So, we've got two angles, and we've got two angles here and two angles there. What else do we need? Well, I marked this with an X right here because the segment between those is reflexive, isn't it? It's congruent to itself. So we have an angle, side, angle, and we're ready to do our proof. Now, let's put this up here so we can see it. Where's a good spot? Let's just stick it right here. Triangle ABC and triangle DBC. And when we put the lines up, what happens? See it over. A goes to D, B goes to B, and C goes to C. That is our corresponding parts, or our corresponding angles, corresponding vertices and points that we need to do. So what's our first? Our first is going to be the given that BC, segment BC, perpendicular to segment AD. Good? That's just given to us. Well, what does that tell us? That tells us that angle BCD is right angle. By definition, perpendicular lines. What else does it tell us? It tells us that angle BCA is a right angle. Why? Well, wow. This is getting a little boring. We have to repeat ourselves. Okay? What do we know about all right angles? There is a theorem back where that says, well, that just simply means that BCD is congruent to angle BCA. Why? Because all right angles are congruent. Okay? Now then, what does that give us? That gives us an angle. So we got an angle. Now, let's attack the side. Oh, we said that BC is congruent to BC. Why? Congruent to segment BC. Why? Well, anything congruent to itself? I look in the mirror, I see myself. That is reflexive. Told you we would build on everything we learned from week 1. When did we talk about reflexive, symmetric, transitive properties? On week 1, but it was week 2 or 3, and we're still using it. We're going to use it all year. So that gets us what? That gets us a side. Let's get that so you can see it. That gets us a side. So we got an angle and we got a side. Now what else do we need? We need that other angle, don't we? Well, let's go up here and get our other given. BC bisects angle ABD. Why? Well, they told me so. It's given to us. Well, what does that mean? Cuts that angle in half, creating 2 congruent angles, or pieces. So that means angle ABC is congruent to angle DBC. And again, I went over here to find out what is the corresponding part to point A. Well, it's D, so I set it up that way. Why? Definition, angle bisector. Okay? Therefore, what? We're there. Angle ABC is congruent to triangle. I'm sorry, triangle ABC is congruent to triangle DBC. Why? Well, here's our other angle, ASA. ASA postulate. Now, let's look over here and see. Let's extend this a little bit. What if they came along and they said, well, wow, we really would like to know, and we would want you to prove that segment AC is congruent to segment DC. How are we going to do that? Wow. Those initials keep showing up, don't they? Number 9, we would simply come over here and say AC, segment AC is congruent to segment DC. Why? CPCTC. And where else do we use CPCTC? Right here, CPCTC, in order to get our corresponding parts. Okay, so that's using the angle side angle postulate or ASA postulate to prove that two triangles are congruent. Okay, have one more of these we want to talk about on this piece.